Yes, very good morning, dear students. Welcome back to online physics class. As dear students, so far we are discussing many concepts in this gravitation chapter, and few many concepts also there. So to complete this chapter, and dear students, last class we discussed about I think importance of universal law of gravitation and about acceleration due to gravity and how we can express acceleration due to gravity. So in the form of mathematical derivations, and what are the relations between g and r, and what are the relations between g and m, and what are the relation between g and rho. So this everything and last class we discussed it clearly. Now today I am going to discuss about so what are the value of acceleration due to gravity on the earth. We know very well the acceleration due to gravity on the earth. We are simply taking 9.8 meter per second square, and how we can derive that, right? And what is the value of acceleration due to gravity on the moon, and what is the value of acceleration due to gravity on the sun, right? And different node points today I'm going to discuss, dear student. It's a very important whatever I'm going to discuss today, very important for higher classes also, dear students. Must just focus on that today class. Yes, dear students, we know very well g equal to gm by r square. Already we proved this equation. So here we know very well, here g is a universal gravitational constant, that is a 6.673 into 10 power of minus 11 newton meter square kg power minus 2. It is in the form of SI unit. And here mass and radius will be vary for different places. For example, for earth it have different values, for moon it have different values, for sun it have different values. So see, you see the mass of the earth is not equal to mass of the sun also. The mass of the earth is not is equal to mass of the moon also. So further different values is there for mass and radius for earth, moon, sun, etc. See here, actually these are the constant for earth. The mass of earth, it is a constant. Well, there is a 5.98 into 10 power of 24 kg, and radius of the earth is a 6.4 into 10 power of 6 meter. Everything in the SI unit only. Now substitute all these values in equation 1. We will get 6.673 into 10 power of minus 11 newton meter square kg power minus 2 into means 5.98 into 10 power of 24 by 6.4 into 10 power of 6 whole square. So here see 10 power of 6 whole square means 6 into 12. It is going to numerator, means it becomes minus. Then minus 12 minus 11. How much? Minus 23. 10 power of minus 23 into 10 power of 24. It is 10 power of 1. Now you can calculate 6.673 into 5.98 into 10. 10 power of 1 is that 10 by 6.4. I will get 9.8 Newton kg power minus 1. If you want, means you also can do. And here see, we know very well Newton means what? SI unit of force. SI unit of force is Newton. We can write it is also kg meter per second by second square, second power minus 2. See, I substitute here 9.8 kg meter second power of minus 2 kg power minus 1. This kg power minus 1 we can also write 1 by kg. Then this kg will be cancel each other. Then meter per second power minus 2 will be left. So for that only, the acceleration due to gravity we can prove it is exactly 9.8 meter by second square. So it is the derivation how we can calculate acceleration due to gravity on the earth. So for that in all problems we can choose maximum cases acceleration due to gravity is 9.8 meter by second square. Whatever the problems they will give in the problems, they are not mentioned acceleration due to gravity, means confirm you can surely can take 9 meter per second square. In such some problems they will mention acceleration due to gravity 10 meter per second square also, right? Especially then mention means you can take 10 meter per second square. If they are not mentioned, means you can take 9.8 meter by second square. And next year students, the value of g on the surface of the moon, right? So g is same as the earth? No, it obviously not same. So for that we see, we know g equal to gm by r square. Again I am taking here, I want to calculate g on moon. G on moon equal to, g is constant, it is universal gravitational constant, but mass of moon by radius of moon. See, mass of moon is 7.4 into 10 power of 22 kg, and radius of moon is 1.75 into 10 power of 6 meter, and g is 6.673 into 10 power of minus 11 newton meter square kg power minus 2. See, substitute all these values in equation 2. See again now 6.673 into 10 power of minus 11, all are in SI units only, into 7.4 by 1.75 into 10 power of 6 meter whole square. Now you can do 10 power of 6 whole square in the number 6 into 2. 12, it is going to number, means it becomes minus. Then minus 11 minus 12 minus 23. 10 power of minus 23 into 10 power of 22. It is now 10 power of minus 1. You can write it is 1 by 10. Then here by 10 will be there. So you can do all these equation using calculator. In this case, absolutely the yellow in examiners also yellow calculator, no problem. Using calculator you can calculate. Almost you are getting G on moon is 1.6 meter per second square. So G on earth is 9.8, G on moon is 1.6. So here I want to calculate relation between G on moon and G on earth. So further I want to divide G moon by G earth, that is 1.6 meter per second square by 9.8 meter per second square. It is nearly equal to 1 by 6. It is nearly equal to 1 by 6. So from this, G moon equal to G earth into 1 by 6. So for that we are telling on moon acceleration due to gravity is very less. That is 1 by 6 times of G on earth. Actually G on earth is 9.8. So 9.8 by 6. How much you will get? That is a acceleration due to gravity on the moon. So further acceleration due to gravity on the moon is a very small comparing to the G on earth. But if you see G on earth equal to 6 into G moon time. See in earth comparing to moon 6 times greater on earth, the acceleration due to gravity. So further this acceleration due to gravity on the surface of the moon is 1 by 6 the times the acceleration due to gravity on the surface of the earth. This is a very important relation, dear students. So you can remember this value. In competitive exams also they will ask this question, right? G on moon equal to 1 by 6 into G on earth. It is also very important. And G on earth equal to 6 into G moon. In higher class also they are discussing this same thing in gravitation chapter. So for that only just you can remember that values and how it will come also we derive. So for that only in competitive exams also they will ask. I seen also many times. Yes, now note 1. So already I told G is a different for different places, and earth will be different, and moon will be different, and sun also will be different. So further here I given note point, the acceleration due to gravity at the surface of the sun is equal to 274. It is a very big value, 0.13 meter by second square. So if you want means the note the values. Mass of the sun is 1.9 into 10 power of 30 kg, and radius of the sun is 6.96 into 10 power of 8 meter. So what is the value of G on sun? G on sun is 274. G sun is how much? G sun is 274.13 meter by second square. Just to remember this value also, right? And see, dear students, another note point. The law of gravitation is we know this law of gravitation is a universal in the sense that is it is applicable to all the bodies, whether the bodies are big or small, whether they are celestial or terrestrial also. So this this law will be applicable for all bodies. Already I discussed this. Next, note 3. It is also discussed. Inverse square law is saying that F is inversely proportional to square of R or D. It means, for example, that if R gets bigger by a factor of 6, then F becomes 1 by 36. Why? Because it's square times. So for that only, R gets bigger by a factor of 6, then F becomes 1 by 36 times of smaller. That is already discussed, I think. Next, free fall. So we have learned that the earth attracts objects towards it. We know very well. This is due to the gravitational force. So see, one activity also the simple activity. Whenever you can take a stone, thrown up, again it will fall. How it will fall? That is activity related already. They given. I am not discussing that. They given in NCERT. It is a very small. Why? Because due to the gravitational force, every object is falls towards the earth, right? Yes. So whenever object falls towards the earth, so under this force alone, so we say that the objects are in free fall, right? That is about definition of free fall. While falling, there is no change in the direction of motion. While falling, any change in direction of motion, there is no change in direction of motion of the objects. But due to the earth attraction, there will be a change in the magnitude of the velocity. So due to the earth, maybe there will be change in the magnitude of velocity. Then direction, there is no change in direction, and change in the magnitude of velocity or velocity, then there will be acceleration also. That only. If any change in velocity, it will cause the acceleration. So whenever an object falls towards the earth, an acceleration is involved. Whenever object falls towards the earth, if change in velocity means an acceleration is involved, this acceleration is due to the earth gravitational force. Hence this acceleration we call it is a acceleration due to gravity. Next, another note point is the difference between G and G. Capital G is the universal gravitational constant. Small g is what? Acceleration due to gravity. So there is a lot of difference is there. The difference between G and G should be clearly understand from previous lectures. So they have different values and different units, right? So G is what is a unit? Newton G. See, if you want to remember, don't blindly remember G units. Why? Because we know very well F equal to G m by R square. Here G equal to F R square by m, right? So then F means Newton meter square, R means meter square, kg power minus 2. Like this you can remember. So for that, don't blindly remember. So the unit of G is a Newton meter square kg power minus 2. Why? Because kg square mm, it goes to numerator, means kg power minus 2. So then between G and G should be clearly understand. They have different values and different units. This G is a Newton meter square kg power minus 2. This G is a meter by second square. And here G is a universal gravitational constant, where G has to be defined as separately for the earth, the moon, the sun, Mars, etc. Right? Already I did G value on earth and a G value on moon and G value of the sun is will be different. Of course Mars also. In each case G will have different value. Also if one goes above the earth's surface or goes into a deep mine, the value of G will be changes. This is about the difference between G and capital G and small g, dear students.